All right, we have reached the last unit that we're going to cover this year. We're going to get back to some more algebra type stuff and some things that are really important, skills that are going to be very, very useful in the coming years. So this is 15.1. I can factor out the GCF and factor by something called grouping. So let's write the word grouping right here. So factor by grouping. And the warm-up starts off like this. I'm hoping some of this sounds familiar. Distributing such as 2 times the quantity 5x minus 9. When we do that multiplication, so we're going to distribute like this. We're going to distribute in. So we get 2 times 5x, that's 10x, and 2 times negative 9, keeping track of the signs and all that sort of stuff. So we get 10x minus 18. That can be thought of as multiplying in. So factoring, which is kind of like the opposite, when we have 5x plus 15, what we can do is we can take out the greatest common factor. The greatest common factor, GCF, is 5. So if we take that out, we're left with x plus 3. That can be thought of as dividing out. So distributing in, that's multiplying in, and then factoring, taking out the GCF, that's going to be dividing out. Now what that means is distributing and factoring are inverse operations of each other. We talk a lot in math about inverse operations. Those are operations that are opposites. They undo each other. Okay, so I'm going to write undo on the end here. They undo each other. So if you'll recall, a factor is part of a multiplication problem. So let's write multiplication right here. Multiplication problem. So when we have instructions that tell us to factor an expression, what we're being asked to do is we're being asked to rewrite the expression as a multiplication problem. Turn this into a multiplication problem. Now, you learned the really basic parts of factoring polynomials when you learned how to factor out the greatest common factor, the GCF we usually just say. So here are a couple of key ideas. So let's keep these things in mind. We always write expressions in what's called descending order. So write the word descending right here. So in descending order. So that means we're going to write the highest exponent first and then the next highest and so forth all the way down, and then we write the constant at the very end. So technically there'd be an exponent of 1 here. And if we had a higher exponent, like say we had 5x to the 4th or something, then that would go first. The next thing is we always take out the leading sign. So let's write the word sign right here. The leading sign is the sign of the first term. So notice how this is written in the correct order, and we've got a negative 4x. What that means is we're going to take out a negative out of this. So we take out a negative. The GCF of these two happens to be 2. So we take out a negative 2, and what's left inside the parentheses is x minus 3. So a lot of times we'll say negative 2 and then the quantity x minus 3. We'll talk more about that and remind you how to take out the GCF in just a second. Now, when we factor everything out of a term, there is always a 1 left every single time. Remember, when you cancel everything off through multiplication and division, there's always a 1 left. So on this one, we've got 8x plus 2. The GCF is 2, so we're going to take out a 2. We're left with a 4x from this term, and we took out a 2. Taking a 2 out of 2, we're left with a 1. And then if there's nothing we can take out, so if you look at it and say, hey, these don't have any common factors, remember we can always take out a 1. Let me make that look right. So we can always take out a 1. So if we've got a 15x and a 7, yeah, they don't have any common factors. So what we do is we put a 1 on the outside, and then we just put parentheses around the original thing. Now, I want to point out a really common mistake. Remember, we are dividing out, not subtracting out. So this is an example of somebody doing something wrong here. So they look at this and say, okay, yeah, the GCF would be 2. I can take a 2 out of a 6 and I can take a 2 out of an 8. So they write the 2 on the outside, and then they say, hey, if you take a 2 out of a 6, you're left with a 4. And if you take a 2 out of an 8, you're left with a 6. That would be if this were subtracting out. In fact, you know that this is wrong because if you multiply the 2 of these together, you get 8x. And if you multiply the 2 of these together, you get 12. So this does not work. So please don't do that. The right way to do this is to take out the 2, but then remember we're dividing this by 2. We're dividing out a 2, so we divide this by 2, we're left with a 3x, divide this by 2, we're left with a 4. So the answer, the correct factoring of this one is 2 times the quantity 3x plus 4. Now, quickly, we're just going to go through and do a couple of GCF problems right here. There are 2 terms here. We've got a 10x and a 35. It's written in the correct order, so we're in good shape there. The biggest thing we can take out is a 5. So again, we're dividing each one of these by a 5. So if you take a 5 out of a 10, you're left with a 2x. And if you take a 5 out of a 35, you're left with a 7. So this right here would be the answer. We could distribute through and multiply. 5 times 2x is 10x, and 5 times 7 is 35. So we know we got the right answer there. Now on this one, we've got a negative 4x squared plus a 15x and then plus 2. So if you look at this, it is in the right order, and the first one starts off with a negative. So we're definitely going to take out a negative. Let's see, we've got a 4. That's a 1, 2, and 4. Those would be factors there. This would be 1, 3, and 5, yeah, and 15, I suppose, and then a 1 and a 2. So really there's nothing we can take out, and we'd like to take out a variable, but there's not a variable in that one right there. So all we can do is take out a negative. So what that's going to do is that's going to change this to a positive 4x squared, a negative 15x, and a negative 2. Now that doesn't look much different, but that is the right answer. And the advantage of taking out a negative is it's nice when whatever we have in the parentheses starts with a positive. So just keep that in mind. And then let's look at this one. They're both negative and they're written in the right order, so we're going to take out a negative. We don't have any common numbers. We don't have any number factors here, but we do have x cubed here and x squared here. There are 3 x's in the first one and 2 x's in the second one, so we can take out that x squared there. So I'm going to be left with an 11 because we took out the negative. We took out 2 of the x's, so there's 1 x left. And then we took out the negative, so we didn't touch the 2, so this is left with a 2. And we took out both of the x's. We took out x squared, so this is it right here. So again, here you can see the advantage of taking out the leading sign, taking out a negative, because we've got one negative out front, and then inside the parentheses, the only thing that's there are just positive terms. So let's take a look at this one here. Let's see what we've got. We've got a 24, we've got a negative 30, and we've got a 6. Let's see. They all have a 6 in common, and because that starts with a positive, we're going to take out a positive. And then notice that they all have an x. So let's write down what's left. So if you take out a 6 out of a 24, you're left with a 4. We took out one of the x's, so it's x squared. We took out, let's see, if we take a 6 out of a 30, you're left with a 5. So I'm going to put a negative 5. And we took out one of the x's, so there's one left. And then let's see, we took out, we took out an x, and we took out a 6, so this would just be a 1 right here, okay? So we're going to go ahead and leave this. Now I'm going to put a little tiny star by this right here. We're going to leave this for the time being, but it turns out if we come back to this and look at this in a couple days after covering a few topics, we could actually take this and break it down a little bit further. And we won't worry about that right now, but we're just going to cover that when we get to it. Okay, so let's talk about the rules for factoring polynomials. The very first thing is we always start out, and I'm going to underline always. This is really important. It's always going to make our work easier. We're going to take out the greatest common factor. So we take out the GCF along with the leading sign. If there are 3 terms, then we're going to worry about that. We're going to determine what's going to go on there, so TBD, to be determined. And if there are more than 3 terms, then we factor by grouping. So we're going to work on these 2 right here, okay? So we're going to work on taking out the greatest common factor, and it seems weird. We're going to skip over 3 terms, but we're actually going to factor some things that have 4 terms. And then we always want to make sure we factor completely, and don't forget to include all the factors in the final answer. So let's talk about factor by grouping. So this is how we factor out the GCF, and then let's talk about how we factor by grouping. So we group terms with common factors together, and then we take out the GCF out of those terms. So I'll show you how we group them together in just a second. And then we look for another GCF in whatever terms remain. So it's kind of like taking out a GCF twice. So we do it once with the first group, and then we take it out again with the second group. Now, if there are 4 terms, we usually group the first 2 together and the last 2 together. Now, we're not going to do anything really fancy with these. It's always going to be these first 2 are going to get grouped together, and then these last 2 are grouped together. Now, I want to point out that I've got a very long bracket underneath this one. It includes whatever sign or whatever coefficient is in front of this. So let me show you how this works on this. So we're basically going to ignore this one right here. So if we were to go through and look at this, we've got A's and A and X, a B and X, an A and a Y, and a B and a Y. So these last 2 have Y's together, and the first 2 have X's together, but none of them have everything that's the same. So we don't have a GCF out of all of them, but if we group them together, these first 2 have an X and these last 2 have a Y. So I'm going to cross this one off. I know you can still see it. Okay, and then we're going to look here and we're going to say, look, okay, this is a greatest common factor problem, kind of like what we did up above. And we'll notice we have AX minus BX. They both have an X. So I'm going to take out an X and I'm going to write down what's left. Well, what's left of an AX if we take out an X? That would be an A. What's left of negative BX if we take out the X? That's going to be a negative B, and then we just close the parentheses. Now, I'm going to cover up the first one, and we're going to look at the second group. So we look at that one and we say, okay, what can I take out of an AY minus BY? Well, notice that they both have a y. So we're going to take out a y. Now, this is really important. A lot of people forget to do this. What we took out is we're taking out a leading sign, so we put a plus right here. This is part of a big, long expression, so we better put a symbol there. Otherwise, people might think it's multiplication. So we're going to take out a y. We start a set of parentheses, and what's left of an ay if we take out the y? What's left is an a. What's left of a negative by if we take out the y? What's left is a b. Okay? Now, that is the first step. Hopefully it's not too bad. We've got a little GCF problem here, little GCF problem here, and then we take a look at this right here. Now remember we said once we get done taking out the greatest common factor of each group, we look for another GCF in the remaining terms. So take a look at this. I've got an a minus b in each one of them. This is x times a minus b, and this is plus y times a minus b. So we have a GCF right here. We have an a minus b. And then we write down what's left. What's left of an x times a minus b? If you take out the a minus b, well, what would be left is the x. What's left of y times a minus b? If you take out the a minus b, what's left is the y. And this is why it's really important to have that sign right there. We don't want to forget it. We slide that down right there. We're left with an x plus y here, and we write these two guys right here. So this is basically kind of a diagram of how this goes. These are both factors, so we write one of those out front, and then we just write down what's left of each term. So I'm going to do several problems like this. It does take a little while to get used to, so we just do this GCF thing over and over again. Okay, now this just takes a little practice. I know it might seem a little bit overwhelming, but if we practice this enough, I did do you a favor, and I did make it so that they're always grouped together like this. We're going to group the first two together and the last two together. They're already grouped the right way, so you can set your mind at ease that way. Now, on this problem right here, we've got 8xy plus 6x, and then minus 20y minus 15. So on this one, let's group the first two together right here. So we're going to look at these guys. So I've got an 8xy plus a 6x. So let's look at the numbers. We've got an 8 and a 6. You can definitely take out a 2. And we've got an x in each one of these, so we're going to take out a 2x. Now, what's left of an 8xy if we take out a 2x? Well, out of the number, if you take a 2 out of an 8, you're left with a 4. And out of an xy, if you take out the x, you're left with a y. And then we've got a 6x right here. If you take out a 2, you're left with a 3. And if you take out the x, yeah, you're just left with a 3x. So we've taken out a 2x out of the two of these, and we're left with a 4y plus 3, and we write that down in parentheses. Now, we're going to group the two of these together, and here's where it's really important to take out the leading sign. So we've got a negative 20y and a minus 15, so we want to definitely take out a negative. And what can we take out of a 20 and 15? What GCF do they have? Well, they have a 5, and again, they don't both have the same variable, so we're stuck with this. We're only going to take out a negative 5. So let's think, what's left of a negative? If I take out a negative, it would be a positive. What's left of 20 if I take out a 5? Remember, we're dividing out, so that would be a 4, and we don't touch the y at all, so we're just going to leave that. And then we're going to take out the sign, so this is going to be positive. And what's left of a 15 if we take out a 5? If we divide out a 5, that would be a 3. Now, the other way that we could do this is we could actually physically write down a negative 5 underneath each one of these, and notice that the negatives would cancel. 20 divided by 5 would be 4, and we'd be left with a y. Negative divided by negative would be positive, and 15 divided by 5 would be 3. So there we go. Now what we look for this time is we've got this term right here and this term right here. We look for another GCF. So I'm going to highlight this again. Those two are exactly the same. So we're going to write that down. We're going to pull out the 4y plus 3. So 4y plus 3 here. And then we write down what's left of this one. We took out the 4y plus 3, so we're left with a 2x. We took out the 4y plus 3, so we're left with a minus 5. And this right here is the right answer. So I guess I should circle this over here. Okay, so that's basically the idea. So I'm going to talk through these next couple of examples. So we'll take a look at C. Again, we'll group the two of these together, then we'll group the two of these together. We've got an m cubed and an m squared. Again, notice that everything's written in the correct order. So we've got 3 m's here and 2 m's here, so I can definitely take out 2 m's, so I'll take out an m squared. We're left with 1 m here, and remember, if we take everything out, there's always a 1 left, so this would be a minus 1. Make sure you've got that sign right there. We've got to take something out of a 2m and a minus 2. We're going to take out a 2. And again, write down this sign right here. Whatever that is, we're going to take out that leading sign. So if we take a 2 out of a 2m, you're left with an m. If we take a 2 out of a negative 2, you're left with a negative 1. And again, notice that these two factors are the same, so we're going to write down m minus 1. and we're left with an m squared plus 2. So these two, we just write down one of them right here, and then we write down what's left of this one and what's left of this one, and make sure we drag that sign over there. So this is it. So notice that it gets a little bit quicker once we've got the basic idea. Again, these are arranged in the correct order. We want to take something out of an 11x cubed minus a 2x squared. They've both got 2x's. So if I take out 2x's, I'm left with 11x. If I take 2x's out, I'm left with a 2. And then out of this one, we're going to take out a positive, because that's the sign right there. And what can we take out of 33x and a minus 6? So 33 and a 6. We can definitely take out, let's see, we could take out a 3. Yep, we could take out a 3. We'd be left with an 11x, because if you divide 33 by 3, you get 11, and divide negative 6 by 3, and you get negative 2. So notice we've got 11x minus 2 in both of those. So there's our common factor of 11x minus 2, and we write down what's left. What's left is the x squared from the first one, the plus 3 from the second one, and that is factored completely. Okay, I'm going to do 2 more. Hopefully that's enough that you get the idea. If you've got the idea and you're in good shape, go right ahead. I do want you to pay attention. Be careful, especially with this one right here, because that has a sign that we have to take out on that one. That one has a leading sign that's negative for that second group. So I'm going to quickly go through this. We've got a 4 and a 14. I can take out a 2. I've got an x squared and an x, so I can take out an x. Let's see, if I take out the 2, I'm left with a 2. If I take out one of the x's, I'm left with an x. If I take out a 2, I'm left with a 7. And if I take out the x, I don't have any x's left. So this is 2x and then 2x plus 7. And then out of here, remember this group, I'm going to take out a positive. Now, I can't take anything out of a 2x and a 7. There's nothing I can take out. So remember, we can always take something out. We can take out a 1. So I'm left with a 2x plus 7. Again, the cool thing about that is if there's nothing that we can take out, if there's no common factors, we're just going to put a 1 on the outside and then write that stuff down in parentheses. And then notice what we've got here. They both have a 2x plus 7. This one has a 2x left, and this one has a 1 left. We circle that and we're done. Okay? All right, this one right here, let's see. We can take out a y. We're left with 1y here. We're left with a minus 8 there. We've got a negative 3y and a 24, so we're going to take out a negative, definitely. And you can take a 3 out of both of those. If you take a negative 3 out of a negative 3y, you're left with a y. And if you take a negative 3 out of a positive 24, you get negative 8. So again, notice that they both have a y minus 8. And we're left with, from the first one, we're left with a y, and from the last one, we're left with a 3. So I'll put parentheses around that, and we're in good shape. Okay, go ahead and do the self-assessment, and then good luck on the assignment. Really good skills to practice here.